Ever looked at an algebraic expression and thought, how do I undo that expansion? That's where factorizing comes in. It's not just about pulling out numbers. The real skill is spotting the largest factor, the highest common factor or HCF, and knowing when you can factor out a variable too. Miss that and your answer's incomplete. Once you've mastered the HCF, the rest becomes routine. We'll break down the examples from easy to challenging, and I'll show you how to avoid the number one mistake students make, forgetting to factor out everything. So let's get started. As you can see, here is a generic way to factor single brackets. And if you have a look at this expression on that left-hand side, you might notice that there is an A. And the A in this point is the highest common factor. I know that it is the highest term that goes into both the AB and the AC. So I'll take out the A, and all that's left over is that B plus C, and I put that in brackets. So this is kind of the idea that we are going to take when we deal with the example questions. As normal, there are 10 of them, and let's get started. Okay, so starting off real easy, we have the 2x plus 8. And hopefully you're going to realize that both of these are even numbers. And if that's the case, you can take out a 2. The next thing you're going to do is you are going to put stuff inside your brackets. And this is when you are going to be thinking about division. What happens when I do 2x divided by 2? Well, that's just going to give me an x. And what happens if I have a positive 8 and I divide that by 2? That's going to give me a positive 4. There you go. For the next one, if you think about the highest common factor in this case, it's going to be a 3. And you hopefully are going to remember or recall that both 6 and 9 appear in the 3 times tables. So now that we've established that we're going to divide both terms through by the 3, 6x divided by 3 is 2x, and a positive 9 divided by 3 is a positive 3. Okay. For this one over here, these are both even numbers again. However, you are going to notice that a bigger number goes into both of them. Okay, so if I were to put a 2, I would have to factorize this out again. But if I go for the highest common factor, which is a 4, I can get the answer in one go. So 4x divided by 4 is an x, and a negative 12 divided by 4 is a negative 3. All right. For question number 4, it doesn't matter if I start with a constant first. Okay, I'm still doing the same thing. I'm looking at my terms individually and thinking about the highest number that goes into both of them. And in this case, my highest common factor, my HCF, is going to be a 5. And now let's divide both terms by 5. 15 divided by 5 is 3. And that 10x divided by 5 is going to give us a positive 2x. All right. Example number 5. If you have a think about where we see a 16 and a 12 in the times tables, they both occur in the 4 times tables, okay? But that's not the only thing I'm going to write. I notice that when I look at my pronumerals, I have an x over there too. So that is also another thing that is common between the two terms. So I will definitely put an x there. Next, I will divide my 16x by my 4x, which gives me x. And when I divide my 12x by my 4x, I'll get a positive 3. There you go. Okay. For question number 6, the numbers, I need to find my highest common factor, and I can see that both these numbers belong in the 7 times tables. So I'm going to put a 7 out, but I'm also going to put an x because that is the pronumeral that is common in both terms. Okay. Now that I've taken out my 7x, I would have a 2 and a y left over when I divide my 14x by this 7x. And I will also have a 3 left over. For the next one, this also appears in the 3 times table, so I will put a 3 there. And then I have an x because both terms contain an x. When I divide through by the 3x, we get a 3, and we'll get a minus x. Okay. For question 8, which times tables do I see 12 and 18 coming through? It is the 6 times tables. And now I'll look for my common pronumerals, and both terms have an a and a b, so I'll take out the 6ab in total. 6 divided by 12 is 2, and when I do a squared b divided by ab, I will have an a left over. 18 divided by 6 is 3, and this time I will have a b left over. Okay. For my next question, where do I see both numbers in the times tables? I'm going to see them in my 8 times tables. Looking for the pronumerals as well, I see that there is an m in both of them, so I will put the m down. And now I'll divide both terms by this 8m. So minus 16 divided by 8 is actually a minus 2, and the m just disappears. And 24 divided by 8 is 3, and I have an n left over. Sometimes you might see this re-expressed in a different way because we do like writing our negatives as the second term. So this is another way to write down the answer for question 9. And the last question we'll do together, this time it's a 3-term, or there are 3 terms in this expression, but it's the same thing. So looking at all 3 terms, I noticed that they are part of the 9 times tables. Another thing I noticed is that 2 out of the 3 terms have a negative sign, so I can put a minus 9. And because they all have an x, I will put that x there as well. Let's start dividing through with that 9x, or that negative 9x. Negative 18 divided by negative 9 is just a positive 2, and we will have x squared left over. Negative 9 into 27 is negative 3, and we'll have an x left over. And over here, we see the exact same thing being divided by itself, so that's going to be a 1. And there you have it. Those are all our examples. So here are some key tips. Always look for the highest common factor in your terms, and notice how we basically relied on the times tables to help us out. Watch out for your positive and negative signs like always, and also check your factorized expression by expanding it. So in all these examples that we covered, if we were to expand these out, we would get the original question. So for instance, if I were to use my loop method again to expand this out, I would get 6x. And for my next term, well, 3 times positive 3 is just a positive 9. So that is a quick way for you to check your answer to see if you've got it right. And there you have it. This is how you expand, or actually, this is how you factorize your brackets. And if you found this video helpful, please like and subscribe for more content.